Thank you very much, Jonathan. So first of all, I would like to thank you for providing me this opportunity to present these pieces of knowledge about local projections. The title of the lab seminar is Dynamic Local Projection, but I will explain you why we included the dynamic, because in fact, local projection is a name of a methodology to estimate impulse response function, and by its sense, as in the local projection methodology introduced by Oscar Jordan, we have a dynamic estimation each reason. So we will come back on that later. So as Jonathan mentioned, if you have questions, feel free to interrupt me about the coding or about the methodology. I would be very happy to answer. So for me, it's a great pleasure to be here, and I will start with the seminar overview. So what we are going to do here is to apply and to know how to estimate local projection using a very well-known software, which is Stata. But of course, you can estimate local projection with whatever kind of software. So you have R, you have MATLAB, you have Go. So you can, as soon as possible, as soon as you can do OLS estimates, you can estimate local projection, which is a very nice thing. So first, so if a practical application will consist in, I will show you some graph, and we'll go to Stata. We are going to open Stata, and we are going to see how to reproduce these graphs. So first, these two studies are not in the good order, they are in reverse order. So we are going to with the first work about Aizenman and all about the impact of holding international reserves, the impact of how this holding of international reserves may help the central bank to smooth real exchange rate fluctuations after terms of trade shocks. So I will come back on that later. And in the second part of the seminar, in which we are going to see a lot of different flavors of local projection to estimate impulse response function, is a recent paper written by William Ginn and me on the impact of geopolitical risk on monetary policy, and we will see what we've done in this paper. So the papers and the code, as mentioned by Jonathan, are available on the website of the seminar and also on my GitHub. And we are going to see a series of applications for local projection. So the motivation, of course, first, geopolitical risk, shock, like wars, tension, terrorism, conflict, of course, are not strictly in a strictly sense economics, but they affect economic variable like inflation, capital flows, and exchange rate. This is something that it is increasingly apparent in the world economy after the global financial crisis in 2008, and an increase into geopolitical tension. But this impact of geopolitical risk shocks or geopolitical tension or geopolitical relationships are always been there into the global economy, but somehow we face a kind of a non-linear modeling of the world economy where when we switch into a state of high tensions, these mechanism, this causal mechanism seems to be more obvious to capture. So basically, we need nonlinear modeling here. So central banks will react to this influence, and here we are, of course, in the Central Bank of Israel. So, of course, it is well known in Israel, but it is not something that is limited to Israel, of course. So they react with their tools. So we have an interest rate, and we have unconventional tools. So what we are going to do is to see how we can use robust econometric modeling to identify this causal mechanism from geopolitical shocks or from terms of trade shocks. I mean, some parts of the terms of trade shocks can be also due to geopolitical shocks, of course. What do we hear by robust econometric modeling? You will see that if you're a macroeconomist, you know that you are very interested to estimate impulse response function. And estimating impulse response function, basically you have two main tools. The VERs, so the vector autovectorial regressions, coming from the works of Christopher Sims in the 80s, and the local projection methodology coming from the works of Oscar Jorda in the paper, one paper in the mid of the 2000s. So what is interesting to the local projection methodology is that recent research by MIT researchers show that this local projection methodology is robust to something which is everywhere in macroeconomics, missed specification. So it seems recent research suggests that local projection are more robust to misspecification. Misspecification can be of various sources. You don't have the right numbers of lags, you have omitted variables, you have non-stationarity, blah, blah, blah. So for economists, applied economists like me, which is interested to estimate this dynamic causal relationship, local projection seems to be flexible, especially in highly unstable environment, where the non-linearity, state-dependent effects are the rule and linearity is the exception. So let us start with the first study in which we are going to replicate. So we have a sample of a large cross-section of more than 100 countries observed in the 2000. We select the 2000 from 2001 to 2020 to have a period where the financial integration is high, and thus in theory it should reduce the need of international reserves in the central banks. And something was puzzling in this study, because in fact international reserves in central banks all around the world are increasingly increasing continuously, especially after the 2008 crisis. So central banks can use international reserves to make central bank intervention on the forex, the exchange rate markets, to smooth the impact of terms of trade shocks. So what is the terms of trade shocks? So terms of trade is just the ratio between the price of export and the price of imports. And in the 80s, you have all this literature about what we call the third world, about the deteriorating terms of trade, which impacted negatively these countries. And what we observed from the 90s is that, in fact, some countries have experienced an increase of the terms of trade because, not in particular, they export oil or energy commodities, or more generally commodities. So these terms of trade shocks, these positive terms of trade shocks, imply exchange rate appreciation. And this is something, and exchange rate volatility. This is something that the central bank would like to limit to have a stable relationship with growth. And you have some papers by Ginn and all showing that excessive exchange rate volatility may weakens growth. So what we discover in this paper, what we discover in this paper is that countries that have weak financial institutions, in fact, use more the reserves, and they have a stronger buffer effect. So it is like the use of international reserves is somehow complementary or somehow used by countries which have not yet reached a high level of financial integration. So we have this, so just to give you a bit of context. So for this paper, the specification will be a panel data, and we are going to use panel data local projection. So let me detail this equation. So on the left-hand side, you have a real effective exchange rate, which will be our explained variable or target variable. And if you see the indices, you see that you have I for the country and T plus H. So we are going to make an OLS regression of this equation for each H. So each H equals 0, H equals 1, H equals 2, H equals 3. Yeah. So on the right-hand side, you have this S, which is the shock variable. And you need to keep in mind that local projections does not solve in any way the question of identification. So to specify your S, your input variable, you can put a monetary shock, you can put a geopolitical risk, you can try to orthogonalize whatever variable, but you need to have something which is in which you have considered the question of identification. So by themselves, local projection, very useful tool to estimate impulse response function, but they do not solve the question of causal identification. So we will have then a gamma H with a lag of a real effective exchange rate to consider the persistence of the series, and then we have a set of control variables. Keep also in mind that local projection have a great advantage to deal with non-stationarity. It is a bit like the lagged VER approach, where you include supplementary lags to consider the persistence in the series. And of course, if you have a non-stationarity, you are in the unit root circle, so the VER will not be stable. But here you can use it. So the control variable will be variable that affect directly the exchange rate. So you will have, of course, the terms of trade, the reserves, the exchange rate regime, for example. Yeah. So first, we need to understand this picture. So I'm going to show you how to estimate this picture, and this picture show that the buffer effect is nonlinear. And the buffer effect, you have a definition here, is the mitigation of real exchange rate appreciation after terms of trade shocks due to the lagged stock of international reserves. So let us start because, let us start the lab. So first you are going to open Stata, you are going to open these file, use the appropriate displaying of the windows, so you can start. So what I can recommend you is always to use a log. Why using a log is good is because when you use a log, you will be able afterwards to make this picture when all the results will be stored. Yeah. And you will make very long, and you can send that to the journal and to show that you exactly estimated what you claim, what you estimated. Yes. So it's very, very useful to do that. So we come back to, yeah. So we charge the data, and I will show you the data. Yeah. Jonathan, please tell me if I have to speed up. Yeah. So the data is here. So you have a country, you have a year, you have a variable which have been transformed, and everything is explained in the paper. So I will not spend too much time here. Of course, when you make a paper, there is a lot of variable, but you don't use in your data. Okay. But So we are going first to replicate the figure 2 in the paper. So first we run a regression, a two-way fixed effect regression with year fixed effect that you can see here, and the fixed effect because I use the command Aizenman in Stata, absorb the country code. In the paper, we used 10,000 bootstrap replication because we followed the recommendation of Bruce Hansen to have a reliable standard errors. So what you can see here is that the higher GDP per capita relative to the US appreciate the exchange rate. This is the Ballas-Samuelson effect. A higher share of government expenditure appreciate the exchange rate, but because government expenditure is targeting most of the time non-tradable goods and non-tradable goods. Yes.
Yes, we have a question from
Sure.
Rana Joy. Yes.
Sure.
Is the panel always required to be balanced?
No. In this example, I use a balanced panel because I wanted to use a package to make the panel threshold regression, and some package in panel threshold regression require the panel to be balanced. But in the local projection exercise, you can have an unbalanced panel regression. So you can deal with that without any problem. That's a very good question.
We have another question from Nitim. Yes, please feel free to raise your hand and then I will give you the floor. So Nitim, do you want to ask your question in live?
Okay. Hello. No, I just want a clarification regarding what is AREG. Normally we use RIG, right? REG. So is AREG something different from normal regression?
Oh, yeah. AREG is a new command coming from Stata, helping you to estimate panel regression model with a high dimensional fixed effect. So AREG, for example, for XAREG, you can include a fixed effect, but with AREG, you can include individual fixed effect, a time fixed effect. If you have trade data, you can include a sectorial fixed effect. You can include a lot of high dimensional fixed effect, and it's very much more coefficient. But if you use XAREG, you will have the same result. Yeah. I hope I answered the question.
Yeah.
Thank you.
Thank you very much. Jakub, do you want to ask your question?
Yes.
Can you hear me? Can you hear me?
Yeah, we can hear you a lot.
I just want to ask how can we check the stability of local projections?
What do you mean by stability?
To make sure that all routes are within the unit circle.
You don't need that.
So always they are stable.
No. What you are going to do, local projection handle non-stationarity. But what you can do is to make your impulse response function over a longer time span to see if you have sufficient data, of course, it's a large time span, if the impulse response function go back to 0. So you don't require to have stationarity, stationarity, yes, but you need to have something that go back to 0 up to some point. Yeah.
Yeah, like not exploding to infinity.
Yes, exactly.
Merci, thank you.
De rien. Thank you so much.
Thank you, Jakub. We have a question from Shimer.
Sure.
Yeah, thank you, Professor. So I would love to ask, in running local projections, how do we discuss our variables in the sense that must our variables be all I1 processes, or must they be I1 or I0 processes, or a combination of I0s and I1s? Like, what should be the stationarity properties of the variables? Thank you.
my answer would be, you have a reference paper about local projection showing that local projection are robust to non-stationarity, and usually they are robust to non-stationarity using lag augmentation. I don't know if you are familiar with the lag augmented VERs. So the logic of a lag augmented VERs is that you have a VER, and if your order integration of some variable is possibly I1, I will add a lag to consider, to take into account this non-stationarity. So there is a literature on that. So I would say that you don't need to pre-test the stationarity when you use local projection. But as for the question of the previous question, you need to ensure that up to some point the impulse response function go back to 0. Yeah.
Thank you.
Are you? Yeah. Okay. Just tell me if it's clear, and I can. Okay.
Yeah, so, it's clear.
Thank you. We have another question. Sorry, yes. Jamel, to interrupt you.
No,
I have another question from Fred Jawadi.
Ah, yes.
Hi, Jamel. Thank you so much for the presentation. So, my question has to do with the previous question. So, for example, if you have to deal with financial data, and when talking about this stationarity is more about the stationarity in the second moment. So when the financial time series is said to be very volatile, and you want to apply local projection. Okay, if I understood it correctly, it is not a problem. It looks like wavelet or something like that. So that's the stationarity, not problem. But what about if the variance is so volatile? Have you to stabilize the variance before going ahead and applying the local projection, or should you can do without taking into account the stationarity in the second moment? Thank you.
Thank you, Fred. Thank you for your question. First of all, I would like to say your knowledge about financial data is probably larger than me. So I must confess my limits here. I didn't go into using a local projection with financial data, but I would say that if you use financial data, you have some variation of local projection considering a stochastic volatility. So I think if you have data which are not macroeconomic data, annual frequency or monthly frequency, of course you have to model volatility. So I don't know too much about it, so I will not go deep into that question, but I think you should carefully think about it. It's a different, yeah, I think you should be careful about it because you cannot make direct inference in the same way I would suggest, but I need to learn more about that. So that's my limited knowledge about the financial data.
Thank you so much. Thank you.
You're welcome. You're welcome. Okay. Okay. So the standard determinants of real effective exchange rates, and you have this here interaction term. And the interaction term is here to say, oh, maybe there are non-linearities in the relation. Maybe if you have a lot of reserves, the stock of international is very big. In fact, maybe you even don't have to intervene on the forex market because people say, oh, these are central bank very, very deep pockets. So we are not going to try to make it change into the exchange rate. So what I can do, I have this equation. I have a non-linearity here. Interaction term, I will pass to Stata the linear prediction using margin. So first, I compute the linear prediction of the real effective exchange rate using this margin command, and I will pass the prediction into a matrix. So first, we estimate the margin, thanks to the previous estimation that you just did. So it will create a prediction, and then using matrix, I will put the prediction into a matrix, and I will save them the prediction into the database that I will show you later. But it is working here, so don't worry if you saw nothing. Maybe we should have calibrated the presentation to have a question just when he created the prediction, but maybe for the next time. So you have all the prediction, and why I choose this time span is because if you make a summary statistic, that's the set where the variables are defined. So I pass the prediction into matrices using matrix here. I clear here the data, and I use SVMAT to have the prediction here. So if you open the data here, you will have the prediction, which is the predicted value here, okay, for the exchange rate at different levels of exchange rate, effective terms of trade shocks, and level of exchange rate reserves. Yeah. So, okay, so we say that. So you have this variable here. Okay, now what we are going to do. We are going to use Python because you cannot directly make a 3D plot in Stata, so we're going to use Python. So first, you search Python if it's not somewhere. I have two Pythons. I have Anaconda and I have Python directly installed. If you don't have it installed, you have to install it, okay? So I clear everything, and I will use the database that I previously estimated from the interaction term and the two-way fixed effect model. And I will send it to Python here. And then I will create the 3D plot, okay? I will not enter a lot inside it, but just to speed up a bit the process. So now what is very nice is that Stata, they made a lot of progress for calling Python very easily from your Stata. So you can, basically you can do everything what you can do. So it creates this picture. So how to read this picture? So you can read this picture by, so if you have an interaction term between X variable, a Z variable, and a Y variable, you are on a 3D plane. So what you can see here is that when you have a terms of trade shock, so for example, the log of effective terms of trade go back from 2 to 3, or from 3 to 4. In fact, you will see that when you have a lot of reserves, for example, log 4, which is a big, in fact, the predicted exchange rate will be lower than when you have a very few reserves, when the log of lagged reserve is 1. So what does this picture mean? This picture means that if you are a central bank and you have a lot of reserves, in the face of a terms of trade shock, your exchange rate will appreciate less. What are the economic channels? You have two channels at least. First is direct intervention of the forex exchange rate market. But of course, you need to see if the exchange rate intervention is convincing and effective. There is a lot of literature on that. And second possible channel is the balance sheet channel. A country with a very high amount of international reserves can stabilize the trading about its currency by saying if the country intervene, it will be very powerful. Okay, I stop here because now we are going to see some local projection, and then we are going to go into local projection for the rest of the seminar. So if I go back to the presentation, so now we are going to see the equation that you just saw in a panel 2 fixed effect model, but using local projection. But there is something that you need to ensure. You have to ensure that this buffer effect is truly coming from your interaction term. So this is something that you can see in the first upper left panel, is that we made the shock on the interaction term. And what you can see is that at horizon 0 is the same as the first equation that I show you. The coefficient is minus 0.02. And then I will make the shock on the interaction plus the terms of trade shock, no effect, and the interaction plus the other term in the interaction, so the lag of exchange rate reserves, no effect. So this is something that can show you that this buffer effect is truly coming from the interaction between the two variables. So what I can do? So this is figure B2 in the paper. So I choose a scheme. I recommend CleanPlot, which is made by Ajad Naqvi. You install logproj. I will not do it here, but you have to install logproj. So logproj is coming from Alfonso Ugarte Ruiz, which is in BBVA research. So first, the writing is very simple. Logproj, the target variable, the exchange rate, control variable, terms of trade, lag reserves, and the shock will be on the interaction term here. I will use other control variable, which would be the lag of real GDP, the share of public expenditure, and international, this is the exchange rate regime by Iletsky, Reinhardt, and Rogoff. For the purpose of the seminar, I put I have a balance panel, but you can do it without balance panel. I include fixed effect. I will use the Z statistics, and I use robust standard errors. I name the impulse response function. I save it, and I told to logproj to make it noisily to see each regression at each horizon, and then I will make some stats. The LCS option is coming from logproj and help you to make the shock, especially in the interaction term. And I give a name for this graph. So let's run it. So what you can see here, you see exactly what the package is doing for each horizon a regression. And we are going to look, for example, as the shock is on that action, we are going to be very interested in this coefficient in particular. Okay? So each horizon, we look at this coefficient. So it's truly OLS regression at each horizon. Okay? And what you can see is that you have a number of, what is very nice in the package of Alfonso Ugarte Ruiz is that you have a number of observations available at each horizon, you have a L squared, you have F stat, and then you have an impulse response function, which is here. And this corresponds to what you have here. Okay? So what is very nice in logproj is that you can make the shock not only in the interaction, but also interaction with one term into the interaction, terms of trade in this case. So I do that. So as you can see, don't have any effect. Jamel? So the effect is, yes?
Yes, we have a question from Fred Jawadi.
Sure.
Yeah, thank you. What does happen if you introduce more than one lag?
You mean for the control variables or for interaction? Yeah. You can introduce.
Yeah. Wait, only one lag?
You can introduce more lag. For example, if I introduce more lag for control variable, I will also show you that later. For example, 3 or 2, you can do that. Let's see what happens. I think, yes. Okay. So in fact, it will include the lags. First, previously I have only one lag for the control variable, and then I included 2. What you can see here. It's very transparent, and it does not change the main result here. So you just have to specify it here. Okay, that's fine?
Yeah.
So it's very simple to do. You can do it. Okay, of course, control lags could be necessary because you may have some persistence, and if you want to control, the question of choosing appropriate lags is very important if you make reliable causal identification. Okay?
Okay.
Thank you, Fred. Okay, so more of the same. So I run everything, and I will use what is very nice with the package of Alfonso Ugarte Ruiz is that he made also another command in the same package. So you install logproj and you have 2 commands. You have logproj and you have LP graph. So one is very nice epic graph is that you can combine all the impulse response function that you have saved here. So you give a name of I have the first is A, the second is B, the second is C, and I save them. Don't forget to save them, and then you can make a graph. So I make this graph. So it's very easy. So you just have to.
Yeah, I'm sorry. We have another question from Rana Joy.
Sure.
Professor, am I audible?
Yes.
Hello. So if we just from a practitioner's view, if we have annual data with like fewer observations, can we still go ahead with such panel framework? That's the question.
Yes, you can, because here is an example with panel data, annual data. But panel local projections, like local projections, they have requirements. So if you have time series local projections, under 300 points, you have to be careful about statistical inference. For panel local projection, you have also a paper by Herbst and Johansen from the Federal Reserve. If I don't, so I can send you later the references. So you need to be careful about the T dimension and the N dimension. So basically, if your T is below 20 years, it's become a bit tricky for inference. So you have to be careful. So you can do it with panel data and annual data, but you need to have some requirements about the size of N and T. I hope this is clear.
Thank you, sir.
You're welcome. So this first graph is using the separate option. So I just put, I can change the horizon here, but I will show you that later. T time title, you can use the horizon name. You choose the lab for the first graph, or the second graph, or the third graph. I use here colors, but you can't see the colors, because if I remove the separate option, I will have some colors here. Yeah, so you can very easily choose what you want to do using the color. Sometimes it's good, sometimes it's not good. You can do as you want. So second example of panel local projection. Now what we are going to do. So when we submitted a paper to the journal, they say, oh, that's very interesting, but there is potentially a problem in your story because exchange rate movements can also cause variation of international reserves due to valuation effect, because usually people in central banks hold reserves into US dollar, less and less those days. But the real exchange rate can impact through valuation effect. So what we are doing here, we are creating two. Basically, we are orthogonalizing the interaction term towards the exchange rate. So we create two regressions in which the variation of the reserves will be orthogonal to the variation of the exchange rate. Okay. So we are doing that with these writing. So now we are creating two variables, which are now not anymore the reserves, or not anymore the terms of trade. It is the terms of trade shocks orthogonal to the exchange rate, and the holding of international reserves orthogonal to the exchange rate. And I use the same writing, and we made the shock not on the original variable, but on the residual variable, a variable for which we have removed the influence of the exchange rate. How the exchange rate will react actually is pretty good because the results are robust. What you can see here is that I put two confidence interval levels, which produce very nice graph. So you have this graph, and you can see that at the beginning, you have this minus 0.02 buffer effect, and then it increases through time. So it was a very new result in the literature. In fact, the buffer effect of international reserves can last multiple years. And I think that's the strongest result in the paper. So you can use the same writing and say, okay, I will look below a certain level of financial integration and see what is happening here. and here above. Okay. So I speed a bit because I spend a lot of time here, but that's good for the rest. Okay.
I think we have a question from
yes,
Fred.
Sure. Yes, please, Fred.
It's in the chat.
It's in the chat.
I can read the question.
Sure.
The question is about how to read the graph. I mean, is it like a normal impulse response function? It does mean when it does not go back to zero, it does mean somehow there is no mean reversion. There's been kind of persistence in the dynamics of the time.
The thing is here, the shocks are residuals. So the residuals by construction are somewhere around zero. I can extend the sample to see if it goes back to zero. But the problem is, if you choose a longer time horizon, you will exhaust the degree of freedom to correct in the correct to compute in a correct way the impulse response function and the confidence interval. So I will not do that, but I will say, okay, terms of trade shocks are shocks. I would not expect that it would be a shock is by definition I0. Same for the shocks on the reserves. And you can believe that the exchange rates are non-stationary. There's a huge, very interesting literature on that. But in a panel setting at the world level, I would not expect that the exchange rates are non-stationary. But of course, you need to make tests. But here, the time dimension is only 20 years. And unit root tests are not very powerful when t is equal to 20. So I will not enter into the debate are the exchange rate are non-stationary or not, but I think here we don't have this problem in this particular application. But of course, it can be problematic. If I have a longer t, I would have checked that. Yeah.
Okay.
Yeah, I hope it's clear. Okay. So the writing is very simple. Look at the code, and if you have questions, you can, after the seminar, send me an email. I will be very happy to answer it. So I close the log, and we can converge to the second part of the seminar. I have to go back to my so basically it's just what we did here. So I hope it was clear, but you can do very easily and very in a transparent way. So don't forget to add the noisily and stat option to see what in each step what has been done to be to detect if there are problems into your setup. So second, we are perfectly on time because we have the midpoint of the seminar. So the second study is about maybe in a central bank is interesting. I presented this paper in Banque de France in last October. So we have a panel data, 18 economies, monthly data over the last 23, almost last 25 years. And what we discover was not in the literature, and I hope that I will be very happy to discuss that with central banker, of course. What we discover is that the reaction to geopolitical risk shock is different. In the short run, central banks may lower the interest rate, especially if the shock is big, to stabilize aggregate demand and to fight consumer sentiment, negative consumer sentiment. But in the medium run, because you may feel, the central bank may feel that the second run inflation just stimulated a bit too much the demand, then you have an increase of the interest rate. And what we discover is that the reaction is stronger after the global financial crisis. So we are going to cover, so panel local projection, we already saw that, state dependent local projection, time series local projection, and at the end, a very nice tool from, in my understanding, is the time varying local projection. So we are covering a lot of local projection here. So you already saw the setup in the time for the panel local projection. Here, I will just ask you to focus your attention about the main specification here, which is the newest, the frontier, so to speak, time local projection, is the time-varying local projection. So it's a paper by Inoue, Wang and Rossi, published in the Journal of Econometrics in 2024, so last year. So here we have the short-term interest rate, which will be regressed at each time horizon as before, a constant, which is a bit different at each time horizon, and we have a shock. The shock in my case is an increase in bilateral geopolitical risk. So geopolitical risk can be considered as exogenous to economic variable. So here we have a kind of a narrative identification. And what is very interesting is that you will have a different impulse response function depending on the time where the shock has been observed. So I will show you that later, but you will have different impulse response function depending on when the shock occurred. Something which is very interesting here is that this kind of modeling, I will not enter into the theory because theory is very complex, path estimators, very complex. But from an applied economics perspective, what you can retain or you can learn is that it is a very flexible tool to estimate different kind of structural breaks, nonlinearity, state dependence, regime change, or whatever. So, okay, so the shock and the control variable would be the standard Taylor rule determinants, inflation, and output gap. So for each month in your monthly data, we will have a specific impulse response function. So that's very good. So I'm going to show you, but first we are going to open the file in the second part. So I close that. So the second part of the seminar, don't save, yes. Second part of the seminar, so you go into that folder. I can close this one if you want. So, okay. So first, as before, panel local projection, but we see the reaction of the short-term interest rate to geopolitical risk shocks. Noisily, I can put the stats. I didn't put the stats. I can put the stats up. I choose the font. I choose a font with time environment, and I choose another scheme, which is to correspond to the journal, to replicate what we have in the journal. So you know you have an inertial Taylor rule in which we included the GPR term here, which is here, okay? The GPR inclusion into the Taylor rule can be justified because the GPR shocks are inflationary and they have also a negative impact on growth. So you can make a model in which a theoretical model when you justify the introduction of the GPR. So what you can see here is the full sample. In fact, the central bank reacts after some time to geopolitical risk shock. And our interpretation with William Ginn, Dr. William Ginn, was to say that it's to fight second-round inflation. Yeah. So that's for the full sample here. In the paper, we use bootstrap computation. I will not do it here because it's a bit long, but I would like to underline that it is recommended to use bootstrap replication to have a better coverage for the confidence interval.
Jamel?
So, yes, please.
We have a question from Fred Jawadi.
Yes.
Yes, Jamal, two small questions. The first one is how do you do to compute the shock of the GPR? Number one, and number two, yes. Is it the GPR-T or GPR-FIT or GPR-ACT or GPR?
Yeah, in fact, the GPR, so the Geopolitical Risk Index, is coming from the work and the website of Caldara and Yacoviello and his team, and we use the bilateral GPR. Why?
Okay.
Because the central bank, I agree that the central bank of, I don't know, Brazil, is very interested into the geopolitical risk of between Russia and the United States. I agree. But the Central Bank of Brazil will be very interested by the geopolitical risk occurring in Brazil. So we wanted to very focus on the bilateral GPR, which is not difference with threat and acts, which could be a very nice extension.
Yeah, but depending, I don't know if I understood it correctly.
Yes.
You have 18 countries in the sample, right?
Yes. Yes.
So look, I don't know which are these countries, but I mean, so basically, even though they are concerned by the GPR shock, the size of the shock of the GPR is variable from one country to another. Looking, for example, taking into account the US, like, okay, the US is involved in a lot of geopolitical events, so the GPR is high. While for other small countries, it could be like, I don't know. I don't know how did you do to control for the difference cost between the size and GPR across countries.
No problem. We are going to do state-dependent local projection. Just wait a second, and I show you that we will make, inspired by the approach of Ramein Zubairi in the Journal of Political Economics in 2018. We are going to see if for big geopolitical risk shock, so selecting the country that you mentioned, the US and blah, 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 the reaction of the central bank is different. And the answer is yes, the reaction of the central bank is indeed different. It is very interesting question. Thank you, Fred. So just one sec. Okay. So if we go back to this slide, I will try to go back to, sorry, Jonathan, I have to respect your wish about being in full screen. I think it's better. Okay.
That's fine, that's fine.
Yeah. So full sample, we only have a reaction of medium run reaction, if you want. But if we go to the developed countries, we see that there is this initial reaction, which is, say, oh, maybe it's why we have this initial reaction. And part of the answer is in what Fred Jawadi mentioned, is that industrialized countries have faced larger geopolitical risk shock. At the exception of Israel, which is in the, Israel and China, which is in the group of emerging markets. So go back to the code and what trying to decipher what happened. So if I go to the code and I say, okay, I will only look at the industrialized country here. So I select only industrialized country. What is happening? I will replicate what I just show you. And when we submitted this paper, so you have it here. So we submitted this paper. Of course, there is some difference because if you use a bootstrap, I will not do it here because it took a lot of time. The confidence interval are more tight. So good question by Fred. He said, okay, maybe the results are driven by country with big geopolitical risk shock. And indeed it is. So what I will do, I will make this graph. So to replicate this graph, what we have here? Here we have, and again, the confidence interval has not exactly that in paper because in paper you use bootstrap replication. What we are going to, so we are going to use logproche to make state-dependent local projection in a very, very simple way. Writing is very simple. So on the left-hand side, you have a reaction of interest rate after big, large geopolitical shocks. So we use a dummy, and we use 1 for the dummy when we are above the 75th percentile for the GPR risk. So we are going to see the top quartile for the geopolitical risk. And the picture on the left is the picture what you see before. when the geopolitical risk is low, below this third quartile, you don't see the same reaction. What does it mean? It means that the true model here is a non-linear one. It's not a linear one. So if you use a linear model, you conflate everything. But it seems that being said, of course, if you are very rigorous, you need to test the statistical difference between the input response, which I'm not going to do that today, but we can do it. Oh, sorry, I'll go back to full screen. I'm sorry.
No, you were in full screen. Jamel, we have a question from Rana Joy, and then after from Fred.
Sure.
Professor, when we are taking a figure for only advanced economies, isn't the observations falling below 18? Like we had total 18, t equal to 18. So if it is even lower than that, will it have any implication on the results?
Can you speak a little bit louder, because I didn't hear you.
Am I audible now?
Yes.
Hello?
Yes.
Yes. So when we are taking only industrial economies in this figure 4, are the number of observations like less than 18? So will that cause any implication if observations are few?
Oh, okay, I see. It's about the sample size. Of course, you can. Okay, let me just show you what you have here. I mean, the panel data you have for the industrialized country group, you have more than 2,000 observation. The T dimension is big because it is a panel. It's a co-integrated panel. You know, T is above 260 points. In fact, ideally, you should have at least 300 points. But you have a recent paper by in a Journal of Applied Econometrics that provides some solution when your T is below 200 points and N is below 200 points. Basically, you have to use cumulated input response function that you can do here. So I would say that in your application is not a problem because T remains very large. I hope I answered your question. Yes. I think there is another question by Fred.
Yeah, thank you. I'm sorry to interrupt you many times.
No.
So maybe one comment about, I like the paper looking at the reaction of the monetary policy and whether we can augment the Taylor rule to increase see, the reaction of the central bank to the GPR. But when I look at again, I'm talking about the sample 18 countries over the period 2020-22. But we know that during this period, some central banks use more unconventional monetary policy. It does mean that I'm not sure whether the short-term interest rate does capture the monetary policy, and then we're looking at how does this interest rate react to the GPR. So somehow, like for example, after 2007, 2008, 2009, it was like quite equal to zero. It was close to zero bound. So that does mean that maybe I'm thinking about like shadow rate or some other boxes for which could capture the monetary policy even during the period for which the bank does not really use the conventional monetary instrument. I don't know.
Yes, that's a good question. I would say that yes, you're right about the unconventional monetary policy part, and we are going to handle that with the time value local projection. But I would say that we are in the conservative margin in a sense that for not in all countries, because you have exchange rate interest rate variation after 2008 in many countries, especially in emerging markets. But of course, it would have been better to have shadow rates. But shadow rates, you have shadow rates for a limited number of countries, so for not all the countries. But of course, I agree with you. I think it would be very interesting to add the shadow rates to fully capture unconventional monetary policy, which is make a lot of sense. I agree.
Thank you.
Yeah, thank you, Fred. Let me show you how to do that, because I think a lot of people came here for that. So I require intention. To make state-dependent local projection using approach, you are first to generate a dummy variable. So the dummy variable which is generated, I can show you the dummy variable here. Let me just pin the selected variable here. Yes. So the dummy variable should have been, I don't know if it's already, let me just check. Not yet. Okay. So I will create it here, the dummy variable. Up. So use the command Aizenman. So what this command do is to create, it creates the threshold from which the geopolitical risk goes beyond the third quartile. So using this information, and I can just confirm that using with some GPR detail, and you can see that from this value, we have in the high geopolitical risk shock observation, which you have here. So using that, I can create a dummy variable, which is D, and I will replace it when the GPR is above the third quartile. And using the writing, so let me just show you, for example, for the US, it will be very, of course, after 9/11, it was above 1, and after it goes down because you have also, in Great Britain, you have also some perturbation here. So for some countries, is a bigger than 1. It's a high geopolitical risk. So, so I made an interaction between the dummy and the geopolitical risk bilateral. I keep, for example, the industrialized countries. I make this LCS. Be careful about the writing here because I put 1 is for the shock. And then if I don't want to see the shock, I put 0 here. So the writing is a bit different, but not too much complex here. I use 15 reasons, 2 lags for the rates, 1 lag for the interaction, some lags, 2 lags for the control. We have a control for the recession, fixed effect, standard errors are clustered at the level of a country, and confidence interval at 95. I save the input response function. I put noisily. I said robust message already clustered. I know I want to have some stats. So first I'll do that. So this is the response that is in your, it corresponds to higher value of GPR risk. And here you have a value when you don't have this risk. And you have a lag because we had a lag in the regression. I can also do it for 0, and I save the graph. Okay. So now I have these 2 graphs, and I will put them together to make the state-dependent local projection. So what you can see is that when we are below this threshold on 75 percentile for the geopolitical risk, you still have this reaction, but it is less significant than before, showing that you have possible time varying effect. So let me combine using the graph combine option here. So when you make state-dependent local projection, you have 2 things that you need to check. First, the threshold. How do you choose the threshold? You can use the third quartile, you can use the first quartile, you can use the median. Something that it is very good and superior to the subsample approach is that by creating the dummy, you do not cut your sample in half or in third or different size. So with infinite number of data, if you use the interaction approach or if you use the subsample approach, they are strictly equivalent. But if you have limited data, in macro we have finite samples and sometimes small samples, I recommend you to use the interaction approach. And then you can even test. The second thing that you have to do, so the first is choosing the threshold. Use the interaction approach, it is better than subsampling, especially with small sample. And the second thing that you have to do is to see if the 2 input response function in different states are statistically different. So we can do that with a simple val test, because when you use this approach, you can make a val test and compare these 2 coefficients at each time horizon that you have into the same regression. So that's very cool. I think that's very cool. Okay, so now we are going to go to, so we made panel local projection, state dependent local projection in a panel. Let's go for impulse response function in time series setup. So now we are going to focus, we are going to use an official Stata command, and we are going to focus on the United Kingdom to start. We're going to make United Kingdom, Canada, and Israel for this time series example. So what you can see here is the picture of short-term interest rate and the geopolitical risk shock in the UK. And as mentioned by Fred, after the GFC, the interest rates are low than before, lower than before, but still you have some variation. And of course, it would have been better to use the shadow rates, but shadow rates are not available for all countries. So what you can see is that you have two big spikes here, so corresponding to 9/11 and the war in Iraq. And you have a long, I think in 2006, I don't remember, but at some point you have terrorist attacks in London. I think it was in 2005, 2006. I don't remember. And after, of course, you have something which is interesting for UK. I will come back on UK about the channels for which this GPR chooses. So we have this picture and say, okay, so if I want to make the picture for the UK of the picture that you just saw in the slide, you can use the official Stata command, which is LPRF. I will remove the quietly thing here. So first, like in the VERs, in Stata, you have to first set a database for the impulse response function. This database is compoundmodel.irf. So LPIRF, so the rate, the controls, the output gap and inflation, and the country will be the UK. I will use here the horizons is 12 months, but I use 12 plus 1 to have the horizons. The lags for the control is equal to 2, and the lag for the GPR, bilateral GPR, is equal to 2. So what the command is doing, exactly as before, it is creating OLS regression. So each of the line that you are seeing here, is OLS regression, and here is a full system, which is nice. Observation in 251. And we have a limited number of impulses and response and control. So we are not worried too much about the input. To make the graph, you have to specify RF graph, the subscription graph, specify that you have dynamic multipliers. I can discuss that. So the impulse will be the GPR and the response will be the rate. You give a name for, use the same name as a year. You can change the level of confidence for, you can 95%. If you have a lot of data, you can make 90% if you want. Create the labels, the grid for each month, and then export it as a PNG. Let's go. So what you can see here is that for the UK is a very interesting example. The UK is especially the example. So when we submitted the paper, the reviewers say, oh, that's bizarre. It seems to not be stationary, blah, blah, blah. In fact, if you increase a lot, the time horizon, I will not do it here, but you have the data, you can test it. If you increase a lot the time horizon, you will see that up to some point, it will come back to 0. But it's a very long time, it's very persistent. So it's not explosive at all. What about Canada? Canada is a bit in a kind of similar situation. It has faced high uncertainty at the beginning of 2000 after the 9/11 and the war in Iraq, and has some geopolitical risk here. I don't know. I'm not a specialist of Canada, but maybe we need to explore why we had a spike here of geopolitical risks. It would be very interesting. And here, of course, it is due to COVID. And you see that the interest rate will be lowered a lot in Canada because they have normalized the short-term interest rate before entering into COVID. So same writing. Again, I will skip this quiet option. What is happening in Canada? Yes, it seems that the reaction is similar to one of the UK. So in Canada, it seems that you have this, this initial short-term reaction seems to be negative to accommodate with a negative sentiment, negative consumer sentiment. What about Israel? Israel is very interesting in this case of study because it is one emerging market with China who faced a lot of geopolitical uncertainty, geopolitical risk, of course. And here the picture is a bit different. Yes.
I just have one question. Why do you say it is an emerging market?
Because it's a classification of the World Bank. I know that there is other classification. In terms of GDP per capita, I would rank Israel into the emerging market group. In terms of financial integration, I will rank it into the advanced emerging market group. So it's like, Israel is like South Korea. It is a border-like case where you cannot, and in terms of central bank practice, you can put Israel with advanced economies because central bank practice is very similar to what we have, of course, early adoption of inflation targeting, etc., etc. So in the paper, we labeled the Israeli economy as belonging to emerging markets, following the very plain classification by World Bank.
In any case, it does not change your results.
Because no. In fact, the results for the panel data is very clear for the group of countries who have been selected in the industrialized country group. But I will show you a graph. For example, that's very good timing for this question, Jonathan. In fact, Israel has faced, I think the combination for Israel is a bit complex to understand because they have also much higher inflation than advanced economies, the rest. And they have more recurring geopolitical uncertainty. So these two things, basically, the UK, Canada, the US, they seem to belong to the same panel because they face infrequent but very big geopolitical risk. They have lower inflation, and they have high level of financial development, financial integration, economic development. In the case of Israel, it looks like more to an emerging economy in some aspects about the inflation dynamics, which is important here because we are doing Taylor rules, augmented Taylor rules.
I don't know since 2005, 2010, maybe. I'm not sure about that, but that's fine. I mean, if it does not, if the classification does not change the result, we don't care.
Yeah, I mean, you saw the results for the full panel. So the results here for all the countries. So putting the emerging markets in and the developed industrialized countries together does not destroy the results, which is in a sense logical. Yeah.
Jamel, you have about 10 minutes.
Yeah. Oh yeah, I have to speed up.
Maybe one just one short comment. Yeah, it is also a matter to complete what it says. It is a matter of explicit target. When you compare advanced countries with emerging countries, so basically emerging countries do not show an explicit target in terms of fighting inflation. So it depends. So that's
actually
the central bank. Yeah, they don't have the same mandate.
Yeah. Actually, that's a very good point. Actually, the timing is different, but it turns out that when we discussed about this paper with my co-author, Joshua Aizenman, he told me, why you selected only inflation targeting countries? I said, no, I didn't selected any inflation targeting countries. It turns out that the biggest economy in the world in the modern era are all inflation targeters. So, I mean, you have de facto and de jure inflation targeters, but here, at least all of these big economies have central bank targets for inflation, which can be different, of course. So let's see what is the reaction in Israel. And it seems to be similar to what we have into more bumpy because inflation is more volatile than in the rest of industrialized countries, but it seems to have this reaction. Okay. So now we are going to see the more advanced example, and I will show you. For example, you have for the UK, focus on the UK. So you have this average treatment effect, which is the average reaction. Now we are going to use the time varying local projection to see whether we have some instability in the parameter. Okay, so how to do that? You need to install the package, which is called TVPREX. So you may install the package. So first, I will have to, I mean, test set is already made. I create lags because lags are not possible to create. You cannot create them into, you cannot use lag in the command, as far as I know. So I create lags. I create a dummy after the global financial crisis. And then I rename the dummy if I want. I create a dummy for high geopolitical risk as before. And then I create a dummy for the recession time if I'm interested to see that. So to estimate the time varying local projection, I base this command about the example in the L5 type TVPREG that you can find it here. So I recommend you to read very carefully this command, which is tvpreg. Yes. So you can read that, and you have some examples here. Read them. Well, the package is wonderful package. You can make a lot of things with that. We can discuss that later. So you have to define this matrices. I didn't change it, but you could use the rate here, the GPR shock, and you put the lags to control. So you use the matrix that you just defined here, the number of horizons, you want the bands, use new US standard errors, and the shock option will make the shock not directly on the GPR, but on a transformation. So I run the code. If you don't have too much lags, it is quite fast. So the shock is on the log because I use this shock on the log of the error here. So the parameter is estimated with OLS. So we have estimation here that are stored in the memory of Stata. It is very clear, you know, that's the model, what we saw in the slide here, and you have a time horizon here. Dependent variable is the rate, and you have 10 independent variable, which is including the shock and the controls. You can use TVP plots, and you have to be careful the reaction of the rate to the GPR. You will also add plot const if you want to see the constant local projection, so the non-time local projection. You give it a name, and then you can replace it. Okay, so what's happening here?
Jamel, usually, you just have 5 minutes.
Yes. So I think I will just make this an example for UK. Yeah. So what you can see here is you think about for some impulse response function, the reaction is very big, but so maybe there is some instability in this story. So how to check that? So I will use the dummy that I created for the GFC. So I will use the set of impulse response function that we observe after GFC. And in fact, you will see that after GFC, the reaction of the central bank is much stronger. than. What about when we have, and to answer a bit of a question of Reg at the beginning, what about if we have a big geopolitical risk shock? We have created a dummy for big geopolitical risk shock. And we claim that in this case, the reaction of the central bank will be stronger at the beginning to stabilize the negative consumer sentiment. It is what you see here after one month, 2 months. You can see that sometimes the reaction is very big, at least -1%. Okay. So now what we are going to do, if you look at this picture on the left and focus on horizon equal t equal 2, you can see that some of the impulse response function are near to -1, and some of them are near to 0. Actually, in the contribution of Inoue, Rossi, and Wang, you can test if this impulse response function are the same. So you can test that, and we are going to test using TVP plot and using plot and horizon 2, and we will have the tests. Oh, sorry, don't put. You have to put the Stata journal scheme. Yes. So what we have here is that after 9/11, the Bank of England, if we believe that whatever is well specified, blah blah blah, reacted very strongly to stabilize consumer sentiment. And after, for the rest of the shock, the rest of the time, it does not reacted because basically they never faced such a big shock like the 9/11. Now, what you can see, go back to this full picture. You see at horizon 15, you have sometimes the reaction is especially strong. When we, and we are going to conclude on that, when we observe such a strong reaction, we observe such a strong reaction, and it is statistically different from the rest of the time, which is around 1.5, 1.5 that you can see, 1 or 1.5 that you can see here. It was just before the GFC. Why it matters? It was just before the GFC because just before the GFC, the price of oil was very high. So at that time, the reaction was stronger to not have second one inflation and imported inflation due to oil prices. So this strong reaction around 3 is what you can see here, and it is matches what we have here. So so I think we covered a lot, and we have a bonus. Because I wanted to give you a bonus. So I will run the bonus. I hope it will. I mean, actually, it would be quite fast. So I cannot fully describe what is happening here, but believe me, it should be just to make nice graph and to show what is happening. So using the data that you have in the tvpreg command, you can superpose the shock and the reaction, the time varying reaction. And what you can see here is for the example is for the UK, I guess, is that actually, in fact, that the shock were very big. We had the reaction, the initial reaction of the central bank to stabilize the inflation, to stabilize the negative reaction of consumer due to this kind of shock. So we believe that this kind of approach is very important because especially for geopolitical risk, if you're interested in geopolitical risk, you cannot use directly. You have to be very careful about the interpretation of average treatment effect. Non-linearity is the rule with geopolitical risk. So I can stop here. Of course, I will be very happy. Sorry about that. I will be very happy to answer to your questions. You have my email.
For sure. We have 2 or 3 minutes just to take some questions from the floor. Sure. So feel free to raise your hand.
Sure.
And then we we will give you the floor to ask your question. Yes, so we have a question from Rana Joy.
Yes.
For this time varying approach, can we also use this for the panel data?
Not yet, not yet. I mean, the time varying parametric projection is has been developed on the paper on which has been published in, I think, 2012 in the Review of Economic Studies about the path estimators, which is an alternative way to model structural breaks. So you have Bain pair literature, and then you have a path estimator literature, and it's still, I mean, it's already very rich, and try to find long time series and study one country. And I mean, even in this setup, you can try to capture some effect coming from the rest of the world. So it's not developed for panel data, but you can still make international spillover into your setup if you want.
Thank you very much. Do we have any other questions? Okay, so we have a question from Fred Jawadi. You're on mute, Fred. Fred, you are on mute.
Can you hear me?
Yeah, perfect.
Yeah, my question is, I said it's my last question. So, so do you recommend to apply any test to see whether you have to apply constant local projection or time varying local projection?
The test is if you use, I mean, the test is here. If at any time horizon, the dotted blue curve always include the black line, you don't have parameter instability, and you can revert to constant local projection. But does not mean that the constant local projection is non-significant. It just means it's not unstable. So don't, if you don't have stability, I mean, it's good for you. The story is more clear and more interpretable. You can rely on the average treatment effect if you have a dynamic causal treatment in your regression. So the fact that the instability is, for example, here, for the UK, you have a reaction which is especially strong. It is different from the rest. But if you look at the local projection, the reaction for the UK after 12 or 15 months is significant. So you have the average treatment effect, which produces a significant sensor. But the significant sensor is not the end of story. It is also significant, but also unstable, meaning that during some periods, the reaction have been not only significant, but much stronger.
Thank you very much, Fred, for your question. Thank you very much for this presentation and the first VIMM lab session. We hope to have other sessions and learning sessions such interesting like that, and maybe with Jamel for the next steps. So thank you very much for being with us, and we wish you a lot of success with your research.
Thank you.
Thank you very much. It has been a pleasure.
Thank you. Bye-bye.